Today we're going to be looking at section 2.6, which is on drawing scatter plots and best fitting lines. So our goal today is to fit lines of data into a scatter plot. Now a scatter plot is just a graph of a set of data points, x and y, used to determine whether there's any type of relationship between the two variables x and y. We're going to talk about three different types of correlation, well, two types of correlation, but the first one is a positive correlation. So that's if our data pairs have a positive correlation if y tends to increase as x increases. So if x gets bigger, then y gets bigger. Okay? So both of your variables are getting bigger at the same time. Okay? Also, if both of your variables are getting smaller at the same time, that would also be a positive correlation. But we look at it as one gets bigger, the other gets bigger. So when we look at our negative correlation, that's if the paired data has a negative correlation if y tends to decrease as x increases. So as one of the variables increases, the other decreases. So when we look at our positive correlation, we're going to see a trend in the data that looks like this. When we put our dots up here, our data points, it's going to go up to the right. And notice here, these variables are increasing this way, and then they're increasing this way. So as we get bigger to the right, we get higher on the chart. Negative correlation, let's go with the same color. They're going to have a trend in the other direction. So in this case, as one of the variables is increasing, still increasing going to the right, notice these are decreasing. They're getting smaller. Okay. And then the other thing we're going to also talk about is, what if there's no correlation? That means there's no rhyme or reason to our data points. They're just kind of all over the place. There's no trend in the data. One doesn't have anything to do with the other. So if we look at example 1 in your book, and that's on page 113, we're going to get, in the first case, if you don't have your books there, it's going to look like this. So is that a positive correlation, negative correlation, or no correlation? Well, obviously, that's a positive correlation. Trend data goes up to the right. X gets bigger, Y gets bigger. So this is a positive correlation. The second graph looks something like this. And this is a negative correlation. So obviously that the data goes down to the right. So as one variable increases, the other decreases. Now we're also going to talk about something called the correlation coefficient. And that's going to be a number from -1 to 1 that measures how well a line fits a set of data pairs. So if it's -1, then the point lies near a line with a negative slope. Okay, so it's almost going to be a straight line down to the right. A correlation coefficient of 0, r equals 0, means the points don't lie anywhere near a line. So there's no correlation whatsoever. And a correlation coefficient of r equals 1 means the point lies near the line with a positive slope. So if we look at this one, this would probably have a correlation coefficient of about 1. If we look at this up here, that one would probably, it doesn't fit exactly a straight line. There's some points all over the place a little bit, but it does definitely have a negative correlation. So this would have a negative correlation coefficient of probably -1/2, or maybe even -3/4. Pretty close to that line, but not exactly. So that's what we're going to be looking at with our correlation coefficients. So example 2 is on page 114 in your book. And so we're going to look at what those have. So if we look at the correlation coefficient number an example 2. The first one, let me draw those on here real quick for you. So here's kind of what those three graphs look like. Now, in the first one, we'll call this one A, you can see that the data tends to go down to the right a little bit, but it's not a very good fit. So we are going to say it has a negative correlation. But obviously it's not a -1, so it's probably about -1/2. Okay, and I think if you look in the book, the actual, they say, is approximately -0.46. So B, obviously there's no pattern here, so this is no correlation, which means that it is 0. Okay, and they say that it's actually a -0.02, so obviously no correlation there. And C, if we look at this one's definitely a positive correlation. And it's a pretty good fit, so we're going to say it has a correlation coefficient of 1. And the actual is approximately 0.98. So that's how you use your correlation coefficients. We're going to basically use -1, -0.5, 0, 0.5, or 1, depending on how close it is. Right? So that's what we're going to be looking at for our correlation coefficients. So in your book, the guided practice is on page 114. So go ahead and take a couple minutes to do that quickly. So pause the video and you can hit play when you're ready to move on. And here are the answers to those 3 guided practice questions. The next thing we're going to talk about is approximating a best fitting line. So here's how we do it. First, we're going to draw our scatter plot. You're going to sketch a line that appears to follow most closely the trend given by the data points. There should be the same number of points above the line and below the line, approximately. Then, 3, we're going to choose 2 points on the line. Yes, and estimate the coordinates of each point. These points do not have to be original data points and probably should not be unless you have 2 points that exactly go through your best fitting line. Okay, so these 2 points do not have to be data points. Okay, a lot of people try to fit those in there. Okay, they don't have to be data points, but use 2 points that are on the line exactly that you draw. And then you're going to write an equation of the line that passes through the 2 points from step 3. This equation is a model for the data. So when it asks you to approximate a best fitting line, they want an equation. Okay, so you're not just drawing a line through your data and calling, hey, there you go, we're good. Okay, approximating a best fitting line means write an equation for that line. I guarantee you that will be on your quiz and on your test. You're going to need to approximate a best fitting line, and you need to write an equation. Some of you are not going to do that. Okay, make sure to write an equation for the best fitting line. So if we look at example 3, on page 115, we're going to take that data and we are going to approximate a best fitting line. So I put a chart here on the right side. We're going to draw these ordered pairs. So the first one we're going to put in is 0, 280. So I have 0, go to 280, which is right about there. Then I have 1, 295. Okay, so that's just under my 300. Then I have 2, 322. So there's 325, so it'll be 322. Then I have 3, 395, so almost a 400. Then I have 4, 425. It's right on there. I have 5, 471. So there's just below my 475. I have 6, 5, 11. And we have 7, 5, 48. All right, so we've graphed our data points. So what we're going to do now is we're going to draw a best fitting line. And you need to make sure to get this as accurate as possible. Remember, we want this to be split the data, about half the points above, about half the points below. Let's see if we can do this. Looks like it goes through pretty close there. All right, so now what we're going to do is we're going to find 2 points that are exactly on this line. So if we look back at our steps here, 1, we draw our scatter plot, check. 2, sketch the line that appears to follow most closely, same number above, same number below. Okay, there's step 2. 3, now we want to choose 2 points exactly on this line. And for all points, I'm going to pick 2 points that are not my data points. And so it looks like I'm going to pick right here, and that is going to go right through 1, 300. Okay, so that's a point that I'm going to pick. And then I'm going to go on my line up here somewhere until I find another one where it crosses. And it looks like right there crosses at, what is that, 5 1/4, 475. All right, so now we have 2 points. Well, we looked in section, was it 2.4, on how to write an equation given 2 points. So the first thing we're going to do is find the slope. So we're going to go 475 minus 300 over 5.25 minus 1. All right, so I forgot to hit play here when I was doing this problem. So we're going to do example 3 from the beginning here. So we're looking for approximating the best fitting line. Again, on the right, I did step 1, drew the scatter plot. 2, we sketched the line of best fit. We drew our line through there just to make sure, again, remember, half our points should be above the line, half the points should be below the line. And then 3, we're going to choose 2 points on the line that estimate the coordinates of each one. So we're going to go through here. And now you have to realize too that not all the points that I pick are ones that you're going to pick, or the person next to you. So we could have different lines. So if I look right here, I see that it crosses pretty darn close to on that line. So I'm going to say that that is the point. I'm going to say 1, 300. And then I'm going to find another point here where it crosses, and I see, right here, it looks like it crosses right on that. So that looks like it's 5 1/4, 475. So there's the 2 points that we're going to use. Now we looked in section 2.4 on how to write equations of lines. And so we're going to do that. We always have to find the slope first. So to find the slope, we're going to go 475 minus 300, subtract the y's over subtracting the x's, so 5.25 minus 1. Well, that's going to give us 175 over 4.25, which is approximately 41.2. All right, so now what we need to do is we have the slope and we have a point, and you can use either one, but I'm going to use the top one because it's going to make the math easier. So we're going to go y minus 300. I'm going to use point slope form. 41.2 times x minus 1. So you're going to get y minus 300 equals 41.2x minus 41.2. And then we add 300. 41.2x. So that's going to be plus 258.8. And so here is the equation of our best fitting line, or our line of best fit. You can call it either one. So we wrote an equation then, example, or step 4 said we wrote write an equation of the line that passes through the points. From step 3, this is our model for the data. So here is our best fitting line. Remember, when they ask you for a line of best fit, that's going to be it. They need an equation. So if we look at our graph here, it looks, that's at 250. It looks like it crosses just above 250, so that's pretty good. And so if we look in the book, when they do this problem, they end up with an equation of y equals 41.3x plus 259. So that's actually really, really close. Now you do have to remember, like we said before, that every single person in here could get a different equation for this line of best fit, which is totally fine, because we're going to use different ordered pairs, but they have to be very close to this equation. Okay? So now we're going to jump down to example 4, and in the example 4, they're going to say use a line of best fit to make a prediction. So in example 3, we graphed alternative fuel vehicles. It says the table that shows in that book is the number y in thousands of alternate fueled vehicles in the United States X years after 1997. Okay, so 1997 was our first date. Now in example 4, they ask us use the equation of line in example 3 to predict the number of alternative fuel vehicles in the United States in 2010. So 2010 is 13 years after 1997, which we were supposed to use. So all we're going to do is plug in 13. So if they said in the year 2000, then we'd plug in 3 after it. So now we're going to calculate what that is. 41.2 times 13 is 535.6 plus our 258.8. And that's going to give us approximately 794.4. So obviously we cannot have 0.4 of a vehicle. So we're going to say that it's about 794,000 alternative fuel based vehicles. That's how we say it. Alternative in the year 2000, I think we're 10. Yeah, in 2010. So once you have your equation of best fit, then you're going to just plug in your data to find out what that is like, or what numbers they're looking for there. All right, example 5. Using a graphing calculator to find the best fitting line. So what I want you to make sure you have right now is your graphing calculator out. And on page 116, they're going to give us directions how to do this. I will walk you through step by step on how to get this, or how to enter this stuff into your calculator. We're probably also going to look at it in class too. So make sure you have your graphing calculator. If you don't have it, pause the video and go find it. You're going to need it for these problems. All right, I'm going to pull up the graphing calculator on the smart board here. So make sure that you have yours with, and we're going to go through this as how to do this. So first of all, we want to enter the data into two lists. You're going to press your stat button. And if you see here, here's our stat button. Whatever button I hit here, let's see. The history will show up down here on the right side. Okay, so now if I want to edit these, I'm going to hit the edit button and I'm going to hit enter. So we're going to enter the data from example 3 and we're going to use L1 as the years. So that's going to be 0, 1, 2, 3, 4, 5, 6, and 7. Okay, so we have those in. Now we're going to move over to L2. L2 is going to be the alternative fuel vehicle. So 280, 295, 322, 395, 425, 471, 511, and 548. Okay, so I have both lists of data now in there. Now we're going to find an equation of the best fitting line, which is a linear regression. Okay, so here's what we're going to do now. We're going to hit the stat button. And now we're going to go over to the calculate menu because we're going to find out what this is, what the equation is, and I want a linear regression. So if we see down here, that's number 4. I'm going to hit that. Now the X list is L1, the Y list is L2. That's good because those are the ones we were using. And then go to enter and hit calculate. And here is the equation that they get. Y equals, and then A, notice, is your slope, and B is your y-intercept. So they'd really get y equals 40.8 or 40.9 x plus about 262.8. Again, this is the exact answer now, which was very, very close to what our approximation was. What was it? 41.3x plus 258.8. So here is how we do the exact same thing, but just type it into the graphing calculator. Okay, so there it gives us the line of best fit. Now, if we want to make the scatter plot, just, and we can see the data pairs to see how well the regression fits the data, we can also do that. So here we're going to hit second and then stat plot. To set up your plot, then select the appropriate one. So we're going to go second stat plot. There we go. So now it came up, and we're going to, if you notice here, all of our stat plots are off. Okay, so we're going to take the first one, and we want this to be a scatter plot. So first of all, we're going to go over here, turn it on, hit enter, and we're going to go down, and this one is the scatter plot. That first one's the scatter plot. So we're going to highlight that one. L1, L2, we have it marked. So we have that, so it looks good. We got to make sure we have all of those things selected. And we hit graph. So it graphed it. Now the problem is here that it graphs it back to our general window. Well, obviously our data is quite a ways off from that. So to get the graph, we are going to have to do a different option. So what we're going to need to do here is we're going to hit the zoom button because our data is so far off of the center here that it's not going to show up. So if we hit the zoom, and if we look down here to number 9, it says zoom stat. What that will do is it will zoom our data or our graph into just a place where we have our data. So if I hit zoom stat, there is my scatter plot. So there are the points that we have, which is what it looks like in the book. And so now what we can do is we can type in the equation, which we said was y equals, and if we pull this up here, we put in 41 point, I forgot what the other one was, but we'll use ours, 41.3 x plus 258.8. I think that's what it was. And then if we graph that, it'll put that line right through those. And so it is pretty close. So that's how we graph scatter plots, and how we kind of a general overview of how to use the graphing calculator. So we'll talk about this in class as well, because I know that some of your calculators are going to do weird things and whatnot. So, but that's how you would use the graphing calculator. So take a second to go through and page 117 to do guided practice question 4. Try to use your graphing calculator to enter that data. Use the page 116 to help you, and then also you can look back at the video to see how we did certain things there. So in number 4, they say oil production. They give you a table. They want to approximate the best fitting line. Use your equation to predict the daily oil production in 2009, and then use your graphing calculator. What I want you to do for example 4 is just use your graphing calculator. Don't worry about the other stuff right now. You're going to have one like that on your quiz, but I want you to use this as a way to get your graphing calculator ready. All right, so go ahead and try to put that in to your graphing calculator. So for example 4 in the guided practice, here is what you should have for your line of best fit. Y is approximately, or y, yeah, is approximately negative 129.8x plus 6,701.6. And then if you graph this, there's your scatter plot, and then it gives you your line of best fit if we type that in. So that's an overview of using your graphing calculator. We're going to do a bunch of this stuff in class, so don't panic if you don't have everything on your graphing calculator figured out. But the big things from section 2.6 is on making scatter plots and using lines of best fit. So all of us can make a scatter plot. We just put our ordered pairs on a graph. Then we need to draw a line through there. Okay, and remember, about half the points need to be above your ordered pair, your line, and about half the points need to be below. Then we're going to find 2 points on that line. They don't necessarily need to be, and probably shouldn't be unless they go exactly through them, points in your table or in your data. And then come up with an equation of a line using those 2 points. Find the slope, then use point-slope form to find it, and then write your equation of your line. And then we also looked at how to do that same thing using your graphing calculator. So here is your assignment for section 2.6.